notation here is for your viewing window. This is your X min, that's your X max, Y min, Y max. Put in the function into your graphing calculator by going to the Y equals key, type that in, and now let's reset the windows. So I want to go -5 to 5 on the X axis, -5 to 5. Oops, let's try it again, -5. Actually, that should be +5. Let's delete that. And then on the Y-axis, the same thing. So you want to go Y min is -5, Y max is +5. Now, yours probably should say Y scale equal to 1, unless you borrowed it from mine, unless you've changed it at some point in the past. But once you get these settings, hit the graph key, and that was lovely. Sound like wedding?
I didn't know this was a wedding.
Yeah.
Was that a wedding? I thought that was a
Wedding or funeral?
That was organ music. That was organ. That was the organ.
All right. So what kind of graph did you expect when we looked at this equation? I mean, what do you expect in general from this graph? A parabola.
Upside down parabola.
Yeah, and I like that. Not only a parabola, but it's opens face down because you've got a negative x squared term. And when you look at our graph, it kind of looks like a straight line, right? So this is not a good viewing window. It looks like a line, not a parabola. So that one's definitely out of the running. So it's too zoomed in. Doesn't even look like a parabola.
So are we're doing it for each one of these?
Yes, we are.
Oh, I see what you're doing.
All right, so let me zoom out a little bit so you can see what I'm writing. And now let's change our sign, change our stuff from -10 to 10 on both axes. There's a trick here. Let me show you that trick. -10 to 10 on both axes is the default setting for your calculator. So if you want to get that real quick, hit the zoom key and then hit zoom 6. That's zoom standard. That sets things up so that you can see this in kind of a zoomed out approach, you know, -10 to 10. So it looks better. But what's wrong with this?
The tip is
It's missing. The tip is missing.
Still too far.
Looks better. Yeah, you can't see the vertex, right? So it looks better. You can't see the vertex. All right, let's continue. So the next one was -2 to 10 and -5 to 20. So let's put those in. And we're gonna have to do that one kind of manually. Make sure you use the opposite key on the bottom of your calculator to type in a -2. Don't type it in with a subtraction key. So -2 to 10, and then -5 to 20 on the y-axis. And that looks good. That looks pretty good. I like that one.
This is the one. I think the other one
This
will
one.
be too.
Well, we've got one more, right? We got one more to look at. So that last one is -10 to 10 and -100 to 100. So let's try that one.
Too zoomed out.
Change the filter. Right?
So -10 to 10 and -100 to 100. And when you hit the graph, there's going to be a couple things I'm not going to like about this one. But what do you see? What are you seeing that you don't like?
It's way too zoomed
Too
out.
small. It's like focused on like one part of it.
Well, it's too zoomed out because you can see
It's like focused on
both the
one
X and the Y
part of
axis.
the.
You just can't see.
Well,
So part of what I object to is that it's a lot of wasted space, right? I mean, most of this graph, almost half of it is just blank, right? I mean, the top half of it. So we don't need to go all the way up to Y max of 100, right? Now, the other thing that you can't really tell on this graph is that there's too many tick marks, right? It's trying to put a tick mark every unit. And it's trying to cram in 200 tick marks from bottom to top. It just doesn't have enough room. So let's take care of a couple things. The first one, we can cut down the window. So maybe we don't need to go all the way up to 100. Maybe we can go up to, I don't know, 20. That would look better. But the thing that I want to educate you on is this scale stuff. I don't need to see tick marks every unit. Maybe we go every 10 or 15 or 20 or 25, whatever you want. So let's go every 10 units. That'll put tick marks at a little bit more reasonable of a spacing. So when you look at the graph, it's not as cramped on the y-axis and you can kind of tell things better. This isn't too bad. I guess because it's a parabola, I'd like to see it more symmetric. So overall, C was our best graph. This wasted too much space at top. Wasted space on top. I didn't like that about that graph. Let's move down
Wasted space.
and try a couple more here. We're going to start dealing with piecewise functions. And they're called piecewise functions because they're really made up of a couple functions that we're going to stick together as one function. So you'll see stuff like that, piecewise functions, in other places. I might not have exactly the right numbers here, but for instance, the price of stamps. So depending on how much your envelope weighs, I think the price of a stamp is it's close to 60 cents now, right? For that first ounce. I don't know, I don't,
My steps.
60 cents. And then once you cross over 1 ounce, then the price jumps up. Maybe those next 2 ounces cost you 83 cents and so on. So it's a piecewise function. It's just little pieces.
So the larger, the more it costs? Like the
Yes. So the more it weighs, the more it's going to cost to send a first class letter. So the same thing is going to happen here. We've got two different functions. You've got one graph of part of the function is y equals 5 or y equals 0, and the other one is y equals 1. So it just kind of depends on what part of the function that you're dealing with the value of x as to what the graph of this is going to be. So let me sketch in a quick graph over here. And I'll do it like this. Just draw a nice little horizontal line. I have a little bit of a bias towards this. Now, this graph changes when x equals 5. So let me just put a little 5 over here, like that. Depending on the value of x, you've got one of two things to deal with. Either y equals 0 for the left part of this graph, or y equals 1 for the right part of this graph. And where does that change? What does this look like? What does a graph of y equals 0 look like anyways? Yeah, nice. It's a horizontal line. Keep in mind that you could write this as y equals 0x plus 0. So it has a slope of 0 and a y-intercept of 0. Basically, it's just the the x-axis. It's y equals 0. So let me graph that. But I only want that graph up to x equals 5. Now, am I going to include what happens at x equals 5?
No, because there's no.
No, because it's a less than, not a less than or equal to. So here's what it's going to look like on my graph. And I graph this horizontal line up to this point, at which point that gets a little hollow dot. I'm not including the point 0 at x equal 5. Then what happens? Well, then my other function takes over. It's y equal 1. So y equal 1, that's another horizontal line. It's y equals 0x plus 1 if you wanted to think of it that way. So here's 1 on the y-axis. And I'm going to start at x equal 5. At x equal 5, what's the value of y? 1. Now, I am going to include that point, so I'm going to use a solid dot there, and then just draw a horizontal line starting from there to the right. So there's the rest of my graph. So this graph is given in pieces, one, then the other. And that's the graph of your piecewise function. That's the graph of f of x there. Now, I'm afraid that's it. Yeah. That's it. That's it.
But like, I
So,
2.2.
so I'll tell you what, we'll make that a little bit more challenging. But before we make it a little bit more challenging, no, you good with that one?
Complaining.
You sure?
I'm probably like 30.
Brandon, that sounded like a complaint. That sounded like she was asking for some harder stuff.
I was just trying to be sure.
Okay.
I wasn't complaining. We gotta make it harder.
I'll take your word for it this time.
Whoa.
All right. Let's take a look at what happens with the next function. All right. And that's going to be this one. Maybe I should have called it g of x. Sorry, I called it f of x again. But again, you've got two pieces. Now, we're going to graph this one first kind of by hand and secondly on our graphing calculators. So make sure that you can follow along. So the first piece of this we'll do in this manly pink. 2x plus 6. That's for values of x less than 1. Now, to try and get a handle on this, really we're going to think of the graph y equals 2x plus 6. And I'm going to make a little t-table. Now, in general, what do you expect from the graph of y equals 2x plus 6? What's that going to look like? Yeah, it's just going to be a line, right? It's going to be a positively sloped line, y-intercept of 6. You know, that's fine. What I would suggest, if you had to graph these for yourself, is you plug in a couple of values. Now, the values we have to plug in correspond to this part of the function. So, less than -1. We're going to cheat a little bit. We're actually going to plug in -1. We'll also plug in -2. If I plug in -1 for x, what do I get for y? 4. And then plug in -2 gives me a 2. So that's going to be, let's see. Let me zoom in a little bit here. -2 and 2, that's going to be down here. But the thing that I really want to emphasize is that we're not including the point at -1. Why not? Why am I not including that one?
There's no less than or equal to.
Yeah, exactly. Thank you, Lucas. So there's no less than or equal to, it's just less than. So we can't really include that. So your line looks like this, right there. So it's that piece of the line. Likewise, we're going to do the same thing for the second part. Is there a question out there? Go ahead. Yeah.
Me?
Anyway, somebody had a question. There's two questions, even better.
Formulating my question. So we only include, do we only include the part of the line that's below -1?
Yes. So let me show you what's going on with, let's see. Let's get rid of this right here. So you've got these two lines. Here's y equals 2x plus 6. Here's y equals 6 minus x. That would be both lines forever and ever. But I don't want all of, say, this line. I only want this line up to the point that y equals, say, -1. So what I'll do is I'll shut off this and I'll only graph part of that line. That's where it stops. Now, because this is,
You mean x equals negative?
x should be less than, not less than or equal to, less than -1. Now, because I'm not including that endpoint, what do I need to put here?
Open circle.
Open circle. So you can actually do that with Desmos kind of nicely. Let's see, I just want to change that to an open circle. There you go. So that's an open circle. Now, for this graph right here, y equals 6 minus x, again, I only want part of this graph. I want to start here and throw out everything to the left of that. I just want everything to the right of it. So I want the values, I want this for the values of x greater than or equal to 1. So let's get rid of this. So now I've only got this part of the graph. And this time I'm going to include the endpoint. So I'll make that a solid dot. And there's my graph. So it works out pretty nice. Now, as far as what this is going to look like on a graphing calculator, well, first of all, let me finish up this part. You could do y equals 6 minus x and make a little t-table for this, x and y. Again, you want to look at what happens at the endpoint, even if it's not there. -1 would go with 7, 0 would go with 6. Those would be some points here, and that's going to give you the rest of your graph. But how do you do that on a graphing calculator? I just showed you how to do it on Desmos. Take out your graphing calculator. Go to the y equals key, and let's clear out everything. Let's put in the first part of the function. Now, there's a little trick in this, and you need to put that first part in with parentheses. So I want parentheses around the whole function, 2x plus 6, parentheses. And then here's a little pro tip. Hit the divide by key, and now we got to put in the condition that x is less than -1. So just trust me on this. I know you're looking at that like, well, why would we be dividing? It's a good question. I'll get to that in a second. X is less than -1. Now here's why they pay me the big bucks, because I know where the less than key is, right? So where do you find that less than key? You're going to hit the second key, then the math key, 2 keys down below that. That gives you your test. And now you've got all these logical operators.
Wait,
so I want second and then math. It's right here. You can see it. It's in red on my second and then math. X is less than -1, parentheses. Now Ryan J was looking at me like, well, why are we dividing by this? That's a good question. What this is it's kind of like an indicator variable. When this is true, it gives it a value of a 1. So if I divide by 1, I'm just going to get the line that I want, because I'm dividing by 1, it's not going to change anything. If it's false, I get a 0. When you divide by 0, it's undefined, so you can't graph it, and it just wipes out the graph. So that makes it a little bit easier to look at. If you don't do the divide by, you can still get it. It just does some other things that I don't like and find appealing. Let's put in the other part of this. The other part would be parentheses 6 minus x. Let's play our same game, divide by parentheses x is greater than or equal to 1. So this time when you hit the second key, then the math key, you want to choose option number 4, greater than or equal to -1, like that. Now, another little pro tip here for you. When it comes time to setting your window, don't reinvent the wheel, all right?
Thanks.
We already have a good idea where we need to see this function. So I'm going to go maybe -6 to 8 on the x-axis and maybe -5 to 8 on the y-axis. I mean, something similar, something that kind of encapsulates what we need to see. So -6 to 8. on the x-axis. On the y-axis, -5 to 8 again. I probably don't want to leave y scale at 1. So let me make that, or I don't want to leave it at 10. Let me make it a 1 or a 2. I don't know, what do you want? 1 or 2? 1. 1? All right, 1.
Number 1.
1 is fun. And there's your graph. Bingo.
Which one was one?
I did y scale and x scale. I mean, the scale doesn't matter so much, just as long as you understand what those tick marks represent. Let's go down and do example D, and then we'll finish up with example, no, it's still part of example C, I guess. So this one, you're gonna need to extend your graph here a little bit. I'm not sure why, but it didn't print well enough. So let's extend this downwards. And then put some tick marks. So -1, -2, -3, -4, -5. And there's 3 parts of this graph. Now we're kind of lucky in this one because the parts of this graph are pretty, you know, pretty easy going. And we've got, for instance, the first part of this graph is y equals -5 for x is less than 1. What's that graph going to look like? What's the graph? Let's just tell me, what's the graph of y equal -5 going to look like? Yeah, it's going to be a horizontal line. Where do I want to stop that horizontal line?
At -1.
At -1. Good. Kyle, is the graph at -5, when it stops at -1, is that going to get a solid dot or a hollow dot?
Hollow.
Hollow, good. So let me put a little hollow dot at -1 and -5. And then a nice horizontal line coming into that. Thank you. Then what happens here? Well, then we got another part of the graph. What happens at, you know, between -1 and 1 with the graph? Where should I draw that? At 3, right? Essentially, this is, you can think of f of x as being y. It's just, you've got y equal this, or this, or this, depending on the value of x. So right now, we're looking at it for values of x between -1 and 1. So you're gonna, so you're just gonna draw the line at 3, y equals 3, between -1 and 1. Solid dot or hollow dot?
Solid.
On one end or both ends? Both ends. And finish it up. Finish up that last one. Yes.
So when we're putting the piecewise function on the y equals, if there's a fraction in the function, we put it double parentheses.
Fraction. I'm not sure what you mean. Where there's a fraction in the function. Where?
Because we put the functions in parentheses and I divide by the.
Oh, that's just to stop the graph from drawing past where our condition is true. That's why we divide it. Let me go back here, and I don't know as though the new ones do it quite as much as the old ones do, but suppose I get rid of this divide by here. If I delete that, notice what happens to the graph. You've got this thing here, and then all of a sudden it's blue on the x-axis. Why is it blue on the x-axis? Well, it's blue on the x-axis because this is false to the right of -1, so that makes it a 0. So you got this times 0 is 0. That's why it's graphing this stuff here. So that gets a little bit messy and confusing. I don't want to see that. So to get rid of that, to make my calculator do what I want it to do, I'm a little bit mean. I say, you know what, I'm gonna divide by 0. So I put that divide by, and now when it tries to graph it to the right of -1, this becomes a 0. Divided by 0 is undefined, so it doesn't have anything to graph. So that's why we're dividing by.
What if the function was 2x plus 6 then divided by x?
You'd have to put all of the function in the first parenthesis and then the condition in the second parenthesis. So if I had a more involved function like you're saying, suppose that I had, let's do g of x is 3x minus 7 over x plus 2 for x less than 5 and x squared plus 7 for x greater than or equal to 5. If you had a fraction as part of your function, you'd have to write it like this. You do parentheses 3x minus 7 divided by x plus 2. And now you've got 2 sets of parentheses all around your function, and then you divide it by parenthesis x less than 5. So that way you've got your function divided by the condition. Now, you do bring up something that I have to share with you. If you're going to do this trick of dividing by a function, you're going to run into problems here, right here, because your calculator is not going to like that. So to do this on your calculator, if you had, say, -5 divided by, you can't type in -1 less than or equal to x less than or equal to 1. Your graphing calculator won't understand it. Desmos will, but your graphing calculator won't. What you would have to do is divide by 2 sets of parentheses. -1 is less than or equal to x, and then another parenthesis, x is less than or equal to 1, and then 2 closing parentheses. It becomes kind of a pain. I don't like it. I think that they could have done a better job with that, but that's just the way their calculators work. So just kind of an FYI on that part of it. Does that help out?
Yeah.
Okay, I appreciate that. So the last part of this then, what's that gonna look like? Amber, what should I draw here?
Open circle,
Open circle, good.
and all the way to the right.
Yeah, arrow to the right, horizontal line to the right. Good job, thank you. All right, so there you are. Yeah, there's your graph. So let's do one last one. A little bit more challenging. It's this one here. We're going to use this part to graph it. And let's start out with a part that hopefully you can kind of figure out without too much sweat. And that is f of x equals 4 for x less than -2. How's that going to look? Yeah, just going to be a nice horizontal line. So horizontal line, and then what?
Hollow dot.
All right, so yeah, horizontal line and then a hollow dot. So let's do that one in orange, this part of it. So that's horizontal line to -2 and a hollow dot. Let's take care of this part down here. Y equals -x plus 6 for x greater than 2. Yeah, this time, you know, unless you want to spend a lot of time with your graphing calculator, let's just plot it. So x and y. What values of x should I choose in trying to graph this? Yeah, 2, 4, 6, you know, 2, 4, 6. So at x equal 2, I'm at 4. At 4, I'm at 2, and then 0. So, yeah, good choices. But there's something you got to be careful of at the x equal 2. What do I have to be careful of at this point, 2 and 4? It's not included, so what am I going to do, Hannah, because the point 2, 4 is not really included? How do I indicate that when I graph it?
Oh, the hollow dot?
Yeah, hollow dot. Hollow dot, and then I can graph the rest of these points, okay? That's going to be 4 and 2, 6 and 0. So this part of it, I mean, the rest of it looks like a straight line, which is really what it is. So I got the hollow dot there, straight line to the right. So looking good there. Now I'm left with what's in between here. So let's see, what's in between is going to be the graph of f of x equals x squared. What do we expect? What's the general shape for that? A parabola. All right, we know what a parabola looks like. If you wanted to, you could plot some points. So some points that you could plot. Well, I would plot values of x between -2 and 2. So -2, -1, 0, 1, and 2. And you get some nice easy points there. The question is, when you graph those points, when you graph this part of the parabola, what am I going to do at the endpoints of the parabola? Solid dots. So that one's going to be filled in, and I'm sorry for the vertigo here.
We don't continue vertically?
Great, good question. Why don't we continue vertically?
Oh, because it will be x2 and -2.
Yeah, it's just for values of x between -2 and 2, so we stop here. It's important for you to see that these holes in the graph got filled in, right? And then we had some other points here and here and here. Basically, those points are just to help us graph this, but you know, you could probably freehand it. I mean, you know roughly what the graph looks like. So here's a question for you. Is this graph a function?
No.
Which one?
The whole thing?
Yes.
I got a no and a yes.
No.
Naomi, you want to settle it? Is this graph a function?
I don't think it's a function.
Don't think it's a function? What does it have to do or be to be a function?
One y output for each input.
All right, one output for y, for each input for x. Was there a visual way we had to test whether or not something was a function?
Yeah.
What was it, Irene? What did it?
Oh, vertical
Line test.
There we go, vertical line test. This passes the vertical line test. Notice that that's got a hole, but then that hole gets filled in. That's okay, there's still only one point there. So it passes the vertical line test for every value of x. This is a function. A weird one, but it's still a function. Yes, sir?
So if it didn't fill in the holes, it would not be a function?
If it didn't fill in the holes, it could still be a function. Because if there was a hole here on both ends, it would still pass the vertical line test because the vertical line wouldn't touch the graph at all.
So it
So-
doesn't have to be a continuous line.
Right, nice. That's a perfect word here that you're going to study more in calculus. It wouldn't be a continuous function, all right? So it would have a hole in it. It'd still be a function, just not a continuous one. Yep. Good job, good job. Anything else on this one? All right, let's put this one to bed and good luck on this stuff.